Let's say we have a parabola, and that parabola, the equation of it will be y is equal to x squared. So let's graph this parabola. We have our y-axis here, and we have our x-axis. If we plug in a few points, we can figure out how this parabola reacts, or we should be familiar with this, so let's just graph it out of memory. Looks something like this, and looks something like that. Let's say we want to figure out what the minimum value of this parabola is. And when we say minimum value, we actually want to figure out what the y-coordinate of the point at which the minimum of this parabola occurs. So the minimum or maximum value is usually defined to, you say the y-coordinate of that point, right? Because the minimum value of this, in this case, is a point. And so when we say minimum value, we want to know the y-coordinate. And we know how to do this with algebra, right? We can find the vertex of this parabola using negative b over 2a, right? In this case, there is no negative b, or there is no b, so that's just 0. And to find the actual minimum or maximum value, we know that's the vertex y-coordinate, so we plug that back in for y, or for x, and we get y is equal to 0. So in this case, the minimum value is 0. And it's pretty clear, right? The minimum this function is 0. And so we don't have to use calculus for that. But I want to introduce the idea of finding minimum values with this. Since we already know the answer, I want to do it with the calculus method as well and confirm our answer. And then in the next video, or maybe later in this video, we're going to do a different problem where you can't use vertex because the graph will not have a vertex, but we're still going to find the minimum or maximum value of that graph. So let's do it. So what we're going to do is we're going to utilize derivatives. What do we know about the derivative of this graph at that point? Well, again, what we know about a derivative is that the derivative gives us the slope of the tangent line at any given point. At that given point, let's draw the tangent line. Let's see how it looks. Let's do a different color. All right, there we go. So the tangent line at that specific point will look something like this. What do you notice about this line? What do you think the slope of this line is? So maybe pause the video here and think about what the slope of that line is. All right, so I'm assuming you've paused the video and thought about it for a sec. The slope of this line would be 0, right? Because we have a rise over run. There's no rise here. It just stays on the x-axis. So the slope is 0. So what we can do here is we can take the derivative of this equation and set it equal to 0. And what we're doing essentially is we're finding the point at which the derivative of this parabola is 0. So I'm going to repeat that one more time. We're taking the derivative of y equals x squared, so y prime is 2x, and we're setting it equal to 0 to find the minimum value of this parabola. Because we know at some x value the minimum occurs, and at that some x value the derivative is 0. So maybe go back and listen to that a couple times so you truly understand what's going on there. So we can actually solve for x here, right? So we get 2x is equal to 0. Divide both sides by 2. We get x is equal to 0. So what that gave us is that the minimum value of this function occurs at x equals 0. So we're almost done now. If we want to find the actual minimum value, we just plug it back in like we did for negative b over 2a. And we get y is equal to 0. So we got the same answer using derivatives. And in this case, we didn't use vertex, but we used derivatives. And we actually know the answer up there, so we can confirm that they're both 0. Okay, now let's do a different problem, which is actually, we'll do another parabola with a max value, and the same idea applies. So let's do that real quick. And then we will go to some problem that doesn't have a vertex where we actually have to use calculus. All right, so let me draw another parabola. And okay, let's see. And for this parabola, what we're going to do is, here, we'll define it as y is equal to negative x squared plus 1. And then we're going to do the same thing. We're going to find the mix, in this case, actually here, let's draw it out first. So negative x squared plus 1 is a parabola that opens downwards, and there's a shift that shifts the graph upwards 1. So if you don't really know what that means, you should review some Algebra 2 videos on translations. So this is how the graph should look like. And what we want to do is figure out the maximum value of this graph. So max value. And to do this, again, we can find vertex. So let's quickly do that, and then we will confirm our answer with calculus. So to find the vertex, we can do negative b over 2a. In this case, our negative b value is 0. So over 2a, that's just 0. So the maximum value occurs at x equals 0. And to figure out what the actual maximum value is, we plug in x equals 0 to the equation. We get 0 squared plus 1. That's just 1. So our maximum value is 1. So I'm going to write it right here. Max is 1. Now let's do the same thing with calculus. Let's do a different color. So what we know, again, about the slope of the tangent line at the maximum value here is we know that the slope of the tangent line is 0. So we take the derivative of this function, set it equal to 0. So y prime is, well, that's negative 2x. And we set it equal to 0 because we know that at the maximum value, derivative is 0. We solve for x, we get x equals 0. We plug that back in, we get 0 squared plus 1, and we get y is equal to 1. So we got the same answer. We got 0, 1, or in other words, max is 1 for this parabola. So we did it with calculus, and we did it without calculus, and our answers are the same. So now that we know how to find the minimum and maximum with calculus, let's do it to a problem where we cannot do it in any other way other than using calculus. So let's define a function that doesn't have something called a vertex. So I'll say f of x is equal to sine of x. And we'll define this function from, let's just do one period. So we'll do from 0 to 2 pi. So 0, we'll say x is from 0 to 2 pi. All right, let's draw this out. And again, this is probably a familiar function, and you might know the max and min value of this function given the domain that I gave right here. But we want to do this with calculus, right? And the reason why I'm picking these functions is because we already know the answer. So we do it with calculus to confirm our answer. So essentially we're developing our tools that way, and then we can use it for functions that are not familiar to us. So the way we graph a sine function looks something like this. In this case, the sine function has an amplitude of 1 because the number next to it is 1, and it repeats from 0, it goes from 1 to negative 1. It keeps repeating. So let's see. So it looks something like this, and then this is 2 pi, and this is some value x2, and this is some value x1. So the reason why I didn't label those is because we want to figure out what those values are, right? Okay, so let's see. We know that this maximum occurs at which the derivative is 0, right? And then this minimum occurs when the derivative is also 0. So let's take the derivative of f of x, means f prime of x. Well, that's just cosine of x, and we set that equal to 0. Now let's figure out when is cosine of x equal to 0 in the domain 0 to 2 pi. Well, cosine of x is equal to 0 at x equals pi over 2, and 3 pi over 2, right? At 90 degrees, and also at, let's see, pi is 180, pi 90 times 3, 100 and, wait, let's see, hold on. 180 divided by 90 times 3 is going to be 270. So at 270, cosine of x is 0, and also at 90, cosine of x is 0. So one of these values is the maximum, and one of these values is the minimum of this function. So let's plug it back in to see which one is which. So f of pi over 2 is sine of pi over 2. Well, sine of pi over 2 is 1. And then f of 3 pi over 2 is sine of 3 pi over 2. And that right there is actually negative 1. So the larger value is the maximum, right? And the minimum, it will be the smaller value. So from the domain 0 to 2 pi, the maximum of this function occurs at x equals pi over 2. And it is 1. So this is max, right? And so x1 is pi over 2. And then the minimum of this function, well, it occurs at x equals 3 pi over 2, and the value of it is negative 1. So x2 is 3 pi over 2. So using calculus, we found the minimum and maximum values of this function by using the derivative and setting it equal to 0.